Hi friend, till now we have covered many concepts of containers and images. We did many practicals of containers and images. How can we create an image? How can we pull or push the image? How can we run a container? How can we go inside the container? How can we install any of our application inside the container? These all we have seen. So I am making this video for the theoretical parts to recap all the things what we have discussed, and this video will be means mainly for the theoretical parts, and I will recap that what the container is and what the images is. So till now what we have seen that what is the containers. So container is a lightweight standalone. Lightweight, what does it lightweight means? Means the application which we have seen earlier, whenever we download any image or that image size is far lower than the real ISO image of any existing file. Suppose I pulled the Ubuntu image. So Ubuntu image seems to be around 70 or 80 MB size in the Docker. But if you will go with the real ISO size of the Ubuntu, then you will find the size will be around 2 GB. So it means that container is lightweight. So whenever any images comes up, so the container takes only the minimal required package. It doesn't takes all the required package. Like in our previous video, we have seen in the practical that when we went inside the container, we were not able to use the command like vim or vi editor command or like curl command. Many commands are there which is not mandatory for every user. So what Docker does, Docker avoids packaging of such commands or such packages. So it just combines only the required package which will be required for all the user. So that is why the size is very reduced and it is called as lightweight. So Docker images and containers both are very lightweight, and we can say container as it is an executable package which is a piece of software that includes everything needed to run it, like code, runtime, system tool, whatever means container is just similar to any operating system or any of our application which we require to run. So container is similar to that. Now containerized software will always run in the same way regardless of the environment. This already I discussed in our first session only. These are the best advantages of the Docker, that Docker images run in any environment regardless of means they don't depends on any environment. They runs this in the same way in all the environment. Why? Because all the containers runs only on the kernel of the host operating system. So all the containers run in the same way. So that is why container doesn't depends on the environment. This is the best advantage of the Docker containers as well as image. So we have seen that what the container is, and now comes the Docker image. Now what the Docker image is? Docker image is the immutable file that is essentially a snapshot of a container. Means this immutable file means we can't modify any of the Docker images. Yeah, we can build our images as per our requirement, but we can't modify or we can't do any changes in the existing image. So that is why Docker image is the immutable image, and Docker image is the template needed to build in a Docker container. Yeah, so you can go through all these documents. I have mentioned all the things point by point, so you won't face any issue in understanding this one. So Docker images are stored in the Docker repository or Docker registry. Already I discussed in my previous video that we used to store Docker images in the Docker repository. Repository is also of two types. One is the public repository, which is Docker Hub, which we are using, and the second one is the DTR, Docker Trusted Registry, which is used by the company because it is you can understand DTR, Docker Trusted Registry, as a private repository. So the company, whoever will post the images of their Docker image, only they can pull it. It is a private repository. It is not accessible to all. So that, and third option is the Docker registry. Docker has its image as a registry itself. So we can pull the images of registry, and in our local system also we can keep the Docker images as inside this registry. Now the thing comes, can we build Docker images? Already we are till now we have seen that we are pulling the Docker images from Docker Hub, like whichever images we required, either Tomcat, Nginx, whichever images we required, we have just pulled it from the Docker Hub and we have used it. But is it possible that we can build our Docker images as per our requirement or project requirement? Yeah, it is possible. So there is two way or two process by which we do it. So one process is manually we will go, I will discuss this two process in a separate video, but I am discussing the point here that what is the process. So first one is the manual process. In manual process, what we does, we just brings up the container, and in that container we modifies or we install some applications, and after the means our requirement, whatever the requirement we do have, if that changes has been done, then we will move out of that container and we will commit or save that container. After committing, that container will be saved as a Docker images. So that is the one process which we call it as manual process. And the second one is the automated process. What is the automated process? Automated process is the making of Docker file. We can create a Docker file. What is Docker file? Docker file is a text file, or simply we can say that is a base scripting type of file. Means we will inside the Docker file we will write all the shell commands what we have to execute, and it will run in the sequential manner. So that when we run this Docker file, so automatically all the steps whatever we have mentioned inside the Docker file, so that will be that all the steps will run, and that our Docker images will be created. In the manual process, to save our Docker images, we use Docker commit command. Commit means we are committing the images. In the Docker file, we used to build the images. So here we use the build command. Okay. Now few things here I discussed. To turn an image into a container, the Docker engine takes the image, adds a read-write file system on top of it, initializes various settings including network, ports, everything. So see what this point means. See what actually Docker image Docker does. See here I mentioned the step point by point. First, Docker downloads any image from the hub or registry. Hub means Docker hub. First, Docker will download the images from the Docker hub. Next, what it does, when we will run that image, then it will create a container. It will generate a container. But after creating the container, also some process follows in the background. So what that process is? Till now what we have seen, that we have just pulled a Docker image and we have run that image. So whenever we just run the image, we can see that image as a container. So in the background also some process goes on, because whenever we have run the container, we have seen that container got some unique host ID, container got some IP address, container got some gateway, netmask, everything container got. Then from where they got? So actually what happens in the background, that after that container comes up, Docker creates a file system and mounts that file system for that container. And that file system is in the readable and as well as writable mode. Means, see, if you will go to the Docker images, and Docker images is only in the readable mode. We can't modify any of the Docker image. So that is said as a immutable. But what Docker container does, that it will be mounted as a readable as well as writable format. Okay. So here comes the layer. What is layer? I will discuss this in a separate video, because this layer is a big concept. So as of now, just understand that Docker image just mount this container is in the readable as well as writable layer. After that, what happens? Docker image just used to assign the network IP or IP, subnet IP, net mask, gateway, whatever is required, everything will be allocated to that container. And after that, that container will be executed in the base shell. Now, base shell, those whoever is aware of the Linux command, they should be aware of that many shell are there. So out of that, base is one of the shell. So base is run on the container. After that, the container is ready and we are able to use it. So this is the process what happens in the background, which is discussed over here. A Docker engine takes the image, add a write file system on top of it, initialize various settings including network ports, name, ID, everything, and then run the images which we say it is a container. Now, in simple term, what is the difference between the container and images? If anyone asks what is the difference between the container and images, then just say in a simple line, container is in the dynamic mode and images in the static mode. Anything which is in the static condition or in the stop condition, that we can say it is a images, and whenever it is in dynamic condition, we can say it is a container. Now here the question may arise that the container may also be in the stop stage. Then can we say it is a images? No, we can't say. Because why? Because whenever we stop a container, we have the access that we can again we can start the container, and once we start the container, we will have all the access to modify the file containers file to install any of the application. We will have all the access. So that is why a container in the stopped state or dynamic state can't be correlated with the images. So in simple term, if anyone will ask what is the difference between Docker images and Docker container, and Docker image is in the static state and Docker images is in the dynamic state. Now you can correlate with the example like a car is standing in your house. So when a car is standing in your house, then that you can say it as a image because it is standing, it is stopped status. And when the car is running on the road, when you took the car outside and the car is running on the road, that car itself can be said as a container. So this is this difference between container and images. A stop car is you can correlate with the image, and a running car you can correlate with the container. So that is, I think, enough. Now you got clear concept between the difference between the container and images. So a running container always has a current executing process. Already we have seen all this with the examples. A container can also be stopped, but an exited container is not this. Yeah, see, the same thing which we have discussed now is mentioned over here. A container can be stopped, but as we have said that any process, any images which is in the stopped status, we say it is Docker image. So if we will stop the Docker container, then can we say it is a Docker image? No. Why? Because a exited container is not the same as an image. It can be restarted anytime, and it will retain its same setting or same modification. We can do whatever we can do with the Docker container. So always remember, Docker container is mutable. We can modify Docker container, but Docker images are immutable. We can't do any modification in the Docker images. Docker image is only in the readable format, but Docker container is in the readable as well as writable format. Okay. Now a Docker image picks up all the application in environment as per our project requirement to make the application. Yeah, already we have discussed this point. See what it is saying, that whatever our project requirement is there, how much application we do need in our project. So we will pack all this application accordingly in the container, and we can run that container anywhere. After we will pack all the applications in our container, we will make it as image, and we can run that image. We can run that image anywhere in any operating system, and we can ship means we can transfer that image from any place to any place. Like I am in India and I want that image to transfer in any part of the world. I can transfer that image easily. Now some people do have questions here that is it possible to transfer or ship the container? No, it's obviously not possible, because a container is a virtual server in your host operating system. If you want to transfer or if you want to ship your container, then what you have to do, you have to convert that container into the images, and that image only you can ship or transfer to any other places. So please remember this point. Now the next point is image or packing parts of Docker. Okay, we have already discussed this. Yeah, container always uses common kernel of the operating system. Yeah, this is the most important point, and I discussed this on the first very day. See what they are saying. Container always uses the common kernel. Means what is the difference between physical virtualization and Docker virtualization is that physical virtualization provisions every server with their own kernel, and in Docker what happens, Docker engine gets installed on top of the host operating system, and Docker engine uses the same kernel of the host operating system, and how much containers we run on top of the Docker image, all the containers will use the same kernel which is used by the Docker engine. So I think you got the concept of what is the how Docker kernel is using common kernel, how Docker engine is using common kernel for all the containers. So what these steps already we discussed. Yeah, I have mentioned all the commands which already we have discussed earlier in all the videos. These all the commands are related to the images and containers. So I will request you all, please do the practical of all the commands which I have discussed here, so that your hand will be free with all the Docker commands. So next, till now we have covered what the Docker images and what the Docker container is, and I think now you are very clear with these two topics. Now we are moving forward. So see now what the questions comes into the mind. Can we create our own Docker images? Already I have discussed now that yeah, we can create our own Docker images, and there is a two process of creating our own Docker images. The first one is manual and the second one is automation. Here I am discussing in brief that what is manual process and what is automation process. In manual process, what we does, first we take any base image. See, always remember, for any of the container, always the base layer will be the any operating system. That operating system can be of any flavor, like Ubuntu Linux, RHEL Linux, Oracle Linux, or CentOS, any operating system it can be. But the most requirement is that the first layer should be, your base image should be only the operating system. On top of any operating system only you can install any application. So first step is that you should take any base image. After that you should start a container. These two steps will remain same for every process. Now the changes comes from the third point. Here what we will do, we will make changes in our container whatever the requirement of our project is. Suppose we require 2 or 3 applications to be installed on that container. So we will install that application in the container, and after that we will come out of the container. Yeah, here the main important concept is there. Never press exit command to move out of the container. What it will do, it will omit all the changes which you have done inside the container. Whatever the application you have downloaded, it will omit everything. So what you have to do, you have to press Ctrl plus P plus Q to save, or to means don't omit that changes which you have modified inside the container. So you have to come out of the container. After that, what is the mandatory process, that you have to save the container as an image. This is the most requirement process, most important process. If you suppose you have followed all these 4 processes and next you are saying that already I modified and I came out of the container by pressing Ctrl PQ, it is not going to work because you have modified your container only. But to use that container, you have to save that container as an image. So here we have to save the container as an image, and to save the container as an image we have to use docker commit command. Docker commit command is there to save the changes. So after you change this, save this change, you will find that docker separate images has been created with the same name, whatever the name you have given. We will see all these steps practically in our next session. But the thing is that this is the manual process, but this manual process is very rarely used in our IT company because we don't have time to go inside the container and we have to do some modification and we have to come out of the container and we have to save it as an image. We don't have that much of time. Then what we follows, there comes the concept of Docker file. We create a Docker file, and inside the Docker file we mention all these steps. See, whatever the steps we followed in the manual process, the same step we will mention inside the Docker file step by step. And what Docker file will do, Docker file will run it in the same way we run our script file. So Docker file is simply a text file where we have written all the commands, Linux command to process it. So see, Docker file contains a set of Docker instructions that provision your operating system the way you like and install or configure all of the software as per your requirement. The same thing I said, that we are in the Docker file we will mention all the steps whatever our requirement is, like we have followed in our manual process. Only the thing is we have to write the steps over here in a Docker file. You will come to know it in a better way when we will say it in a practical. So Docker file is just like our base script. Already we have said that we run our base script file. In base script file, what happens that the script runs from one line to the other line and it executes the command in the same way it is written inside the base script file. So the same thing happens in the Docker file as well. So it is very similar to the base script. So to see in the Docker manual process, what we have seen in the manual image process, that we uses Docker commit command to save our images. But here actually what we are doing, we have created our Docker file, and anytime when we require the image, we just have to build the image. We have to run that Docker file. So what is the command over here? Docker build command is there. With the Docker build command, we will just build our images whenever and wherever we require. So this is the advantage of Docker file. It takes less than a second to create any image. So everyone in every IT companies follows this Docker file, and to run a Docker file, Docker build command is there. Okay. So already I mentioned the link also. If you will go to this link, you will get better idea of Docker file. They have mentioned everything in details over there. So I think this is sufficient for the theoretical parts. In next video we will see how can we create Docker image in the manual process as well as in the automation process. Both process we will see separately. So as of now I will request you to please do practical as well as parallelly, means along with the watching with this video, please do the practical as well. And I am uploading all this image, all this document and PPTs and whatever I have in my Facebook group Devops G. So I will request every one of you to go to this Facebook group and you can download this document from there. So that is sufficient for today. We will catch up in another video. Okay, bye bye.